Okay, hi. I want to show something that was kind of bothering me about this edge stuff. Let me flick this on. This is a little sample here where what we've got is, this is, we'll just call it forest, and that's not forest. It's just a mask of 0 and 1. I tried to do a big color shade here so you could see the difference between the two. And then we do a Gaussian filter. Watch this edge right down the middle here. So when I turn this on, whoops, let me come over here and we flip that on. And see, we get values off here to the right that aren't even in forest. And I think the thing we were always trying to do is kind of have right here at the edge, it should be basically almost 0, and then work our way in from there. Or, you know, some value that's reasonable here. So I try to do some things here where, here I'll show you this one, where I just simply dropped everything to the right that would have been part of the Gaussian filter. But then the thing you get here is it's still not 0. It just kind of cuts off later. So let me show you what I've been working on for, just kind of going back to the original math problem of the convolution. I'm like, well, I really want that to go to 0. Like when we go across here, it's like high, and we want to go that down to 1. So let me show you what I've been working on for that. Let me try to change my capture here to this. Is that? Okay. So we got here, this is a convolution kernel here. Just may recognize it as your just a little classic Gaussian. And what we're going to do, I'm going to turn on an edge here. So what we've got, this is kind of like, so I colored this red on purpose, so it kind of remind you of the edge that you saw before. And so everything to the left here, that's going to be within the forest, and everything to the right here, that's not. So that's why I have defined this thing here to be basically 1 for when it's less than 0. And it's no coincidence. I've dropped a point here and here, dropped a point at -5 and -1.5. That's our 5 kilometers and 1.5 kilometers. And let me just show you here. In fact, I'm just going to do something right here on the fly. Let me show you the classic convolution. So we'll call this running out of equations here. We'll call this b of t. Whoops. B of t equals. Okay. And why does that not show up? T. Oh, there it is. There it is. There it is. Okay, great. So we've got here this green. This is literally the result of a convolution. What this is the function which you're doing the convolution over. In that case, it's just our 1 here. And then this g, this is the convoluting kernel. And that's our, I call it g because it's a Gaussian here. And what you can see is the r shifts as you do the integration. And normally you do these things positive to negative infinity, but here we're just going out to like -100. See, if we only went out to 1, or -1, we would get a different value. Seems awful slow in calculating here. Oh, there you go. See, it. And so what it's doing here is it's only going, well, it's defining t everywhere, but what it does is like for every point, like it'll come along here and it'll only go like 0 to 1 back and forth like that. That's not quite what we want. So, sorry, what it does here is it takes this integrating kernel and then it'll slide it along this one up here. I said that a little bit backwards. Anyways, as you can see, as you adjust the like sigma here, you kind of get this like shifting value of the resulting kernel. And actually, let me kick this back to -100 again. And so you can kind of get a problem. It actually goes up here to 2.5, because 2.5 is like I guess it's not 2.5. I don't know why I thought it was. Oh, I see. I'm sorry. When it's like right at 1, it's about 2.5, because that's the value if you like integrate under this whole Gaussian curve. It's about that much. So I'm just going to normalize that here with this. And it's saying, oh, sorry, I've done a couple things here. Let me just take this off. Oh, I've already spoiled it. Okay. So if we take, if we just divide our integrating kernel by basically the sum of what the Gaussian would be, this kind of normalizes it. So I'm going to turn off our kernel now. And now this thing that we have here, this is kind of the picture that we just saw in QGIS. I'm going to flip back to it here. Sorry, this takes a little bit of of work for me to flip back and forth. I'm sorry. Here we go. Okay, so what this is kind of showing like the one going, oh, I'm sorry, it's more like this one here. So this is kind of showing like the one going all the way down to 0 here, but it's crossing the edge right at this point here. That's the picture that we have over here on the graph. So I'm going to change back to the graph and then we'll just work from there because I think I have an idea for this. So it's kind of interesting because as you can see here, no matter what you choose for your integrating kernel, it just kind of rotates around 0.5 here, which honestly actually isn't a surprise since like at this point exactly here when you're doing your convolution, you're literally getting half of your Gaussian kernel at that point. So that's why it goes down to 0.5. We honestly don't care about this part to the right because that'll never be in the forest. So what we want to do is we want to shift this down so it really hits 0. And then we want to scale it up so this tail back here goes all the way to 1. So that's what I had before. It's easy to shift down so you intersect with 0. We can just subtract off a half. And you can see it'll go down much further than I thought. What's going on here? Oh, I see. I don't know what's going on there when that happens. And then we want to scale this whole thing up by 2. So we'll just multiply the whole thing by 2. And, okay, great. And then we get that picture there. And then I think I can even, let's just, can you just cut that off at 0? Let's see what happens here. Ah, great. Okay. So it's kind of interesting because now this is like a little like this is what we want. And what's interesting now is what do we pick for sigma such that we kind of get a 0 down here right at the end of the forest. But then up at our key points, we kind of want it to start to decay. So I've plotted 2 points here, one at 5 and one at minus 0.5. And this is very graph calculator-y solution. If we kind of zoom in here, we can kind of adjust this k back and forth. And you see, no surprise, the bigger we make the sigma, that's kind of the further we want to like go in and have the forest edge be. It kind of like dips down a little bit farther than we expect. So I'm just going to sneak this up here, and it'll always be like close to 1. But let's just take a look at that. That's a sigma of 0.38, and we'll just cruise out here. And we already know it drops down to 1 like that. And I don't know if that's like too strong of an effect or whatnot. But you can kind of see now, like I feel like we have this graph of a thing that we could actually want. And likewise, for our 0.5 out here, I'm going to remember that 0.38. Hang on, I'm just going to write that down on a piece of physical paper. 0.38. And then if we want to kind of do the other integrating kernel, when does it start to matter for 0.5? We just kind of sneak this up here. And this this convolution should start to pull itself down. And we can just kind of go along there until, I don't know, something like that, huh? Maybe a little bit back up. I don't know. What do you think about 1.5? Something like that. Then we can kind of get this nice little like Gaussian fall off like that. And obviously this isn't the amount of carbon that's stored in here, but it is maybe like reflective of the amount of edge effect. And you can see it gets it over the whole range. It's got a nice Gaussian decay, and then we would think that whatever our machine learning model, oh, look at that, we can actually find the points there. We could see whatever our machine learning model would hopefully adjust for that. So I'm going to write down this 0.149 here. Okay. And so those are the changes I'm going to make. I'm going to use those new 2 integrating kernels, 0.38 and 0.49, not divided by. Then I'm going to adjust this kernel so it actually goes down to 0 at the edge. And then let's try another pass on that. All right. Thanks for watching. Be right back. I should change that. Chatting. Oh, that's me. Hello or goodbye.